Okay, so now for the corn burner. This is just a stack here that comes off. A lot of people have asked me. They've said, you know, what are those? What are those boxes there? What they are is they're a clearance to where I can put the heat exchanger in the fire, or it goes in what I call a huddling chamber, and it's out of the fire. Whereas when it's in this position, it's in the fire stream. Fire stream comes out of here, straight up. This layer of heat exchangers here is the block heating heat exchangers. And if you look down inside, there's some jets in the afterburner assembly. One thing that's going to happen is there's no space here for a superheater. It's right there. I mean, it's a 1/2 inch clearance, and I need a good solid 4 inches clearance to put the superheater in there. So what we're going to do is we're going to raise this up one stack, and that stack will go right over this block heating heat exchanger, and then we'll have a superheater, and then this remaining assembly for the injected water. It's a convection unit. You know, when I first designed this unit, I didn't realize the value of forced circulation, but it does work. It does produce heat, and it can get the pressure of the injectors up to 5,000–6,000 pounds, no problem. But it just doesn't have the capacity. The idea is, you know, with a flash steam, you're just using a really small duration of where the injector sprays a little bit of water into the cylinder. And at the time that I built this unit, I didn't realize that I needed the superheater and needed to pull live steam from the exhaust, superheat that steam and put it into the engine. It's central to the issue of a flash steam concept, because anybody that's looked at a steam table knows that if you heat up water to 700 degrees Fahrenheit and you have it at 3,200 pounds pressure, and you release that, you're going to only get 50% steam. You're not going to get 100% steam. It's not going to work that way. So water can't contain enough energy internally to flash 100% to steam. So we need a couple additional mechanisms to help that. One is the block heating circuit, which this whole reservoir is full with a heat transfer fluid. You know, when I'm just running the corn burner, I use water in here and it boils pretty aggressively. But when the engines actually run, there's hot oil in here, and it's a special heat transfer fluid so it won't smoke or catch on fire if it gets to 400 degrees Fahrenheit. This is just some insulation and stuff, and it's covering the plumbing. This is the plumbing to the block heating circuit. And see, this intake port has got to go to that extra level that's here, and then the extra level that's here is also got to feed off of. It's probably going to go straight through this plate to the superheater to pick up the exhaust, superheat it, and then compress it in the engine. And you got, on this engine, you have a exhaust. You have an exhaust valve. Under this, tap it here, and then you have an intake valve that's just actuated by the vacuum of the piston moving back. So when I designed this, I didn't have that part of the theory that well understood, and I thought that the block heating was sufficient to cause a reaction, and it is, but it won't last. You could run the engine for maybe 5 minutes, and then eventually it would overtake the block heating, and then the engine will quit running. Now, if you have a superheater and you're drawing live steam in, you're superheating that live steam, you're aspiring it into the engine, the engine's pulling it into with a vacuum, then it compresses that mass of steam. Well, that mass of steam has so many BTUs to it. Superheated steam, you're talking over 2,000 BTUs, whereas water is like 180 BTUs. So steam it's got a lot of heat content to it, and between the block heating circuit, the preheating of the injected water, the aspiration of superheated steam, when all those things come together and the water is injected into the cylinder, you can achieve 100% evaporation or flashing of the water that you're injecting in. But it's interacting with several different mechanisms. One of the mechanisms is the block heat. Another mechanism is the aspired superheated live steam, and the preheating of the injected water. I'm expecting to be able to hand crank this over. I'm expecting to hand crank this over and develop at least 600 psi, maybe 1,000. And if it does that, then it's worth it to go forward with all the other modifications. So that's pretty much it. I just wanted to test out the camera, and this should help me do that.